Okay, we have add and subtract mixed numbers. A couple of things you need to make sure you have. Make sure that you have something to write with. Make sure that you have a notebook. Make sure that you are turned to page 299 in your book. That's volume 1, 299. Add and subtract mixed numbers. Okay, that's the title. Okay, so a couple of things that you want to make sure that you have on your notes. Very, very important that you have a title. Okay, put a page number on there. Okay, you could write the essential question. What happens when you add, subtract, multiply, and divide fractions? Today we are going to be adding and subtracting these fractions, but this time we are going to be dealing with these mixed numbers. So they're still fractions, but they're mixed with whole numbers, and we're going to be adding and subtracting them. Okay, so it happens. You know, you're gonna come across this quite a bit in real life, where you're gonna have mixed numbers. If you happen to go to get pizza and you buy 5 pizzas, and the leftovers, you might have more than one pizza. It'd be a whole pizza with a fraction of another that are leftovers. Okay, therefore you have a mixed number. And you might say, Mom, we have 1 3/4 pizzas left. There you go. 1 3/4 or 1.5 pizzas. Okay, or maybe you're doing a recipe and it calls for a 1.5 cups of milk. So it's 1 cup plus 1/2 of milk. So it's 1 1/2. Okay, so mixed numbers, that happens. Okay, so we're just going to have to learn how do we add them together? How do we subtract them together? And what does it mean to have that whole number and fraction? Okay, so make sure your notes are all set up. Make sure you're ready to go. Remember my problem that we do on our examples on the left side. This is your book on the right side. Sometimes I follow it, sometimes I don't. It is there, but you could always look in your book and see if there's something different that will help you out that I have not said, or I might add more that your book didn't have. So it kind of goes both ways. So number 1, they give you 7 4/9 plus 10 2/9. And the first thing that I noticed, just like from my lessons before this, is that I have the like denominators, or they are the same. So I'm going to set this up. I'm going to set this up as 7 4/9. I'm going to do it going from left to right. 10 2/9. And what I'm going to do is I'm going to separate everything out right now, because I can. We're adding. So because we're adding, I can take my 7 and my 10, and I can place that over on the side and say, okay, well, my 7 and my 10, and when I add it up, I get 17. Okay, I'm going to hold on. That's my whole number right now. Okay, then I have 4/9 and I have 2/9. Okay, because I have the same denominator, just like I did before on like fractions. So if you go back to the video like fractions, you'll notice that I put the 9 down below because it's the same denominator, and then I put 4 plus 2 up top. So now I'm dealing with my fractions, or the fraction portion of the mixed number. So 4 plus 2, well, yes, you guessed it. I'm going to get 6/9. Okay, well, my 6/9 can be reduced. It can be reduced, and remember, you can use 2 or 3. Start with 2. No, 2 does not go in the 9s. They go to 3. Yes, 3 goes into 6 and 9. 3 goes into 6 2 times, and 3 goes into 9 3 times. And so I get 2/3. So my fractions add together, 4/9 and 2/9 add together. They gave me 6/9, and then I reduced it to give me 2/3. And then I'm going to put it all together. I'm going to take the 17, and I'm going to take the 2/3, and I'm going to push them together into a mixed number, and I'm going to get 17 and 2/3. Now that's one way to do this. That is one way. Notice in the book they went straight down. This is more of the 4th grade method. It's the same way. It looks the same. I just want you to see which one's the whole number versus the fraction. Okay, on number 2. On number 2 we notice that all of a sudden now my fractions don't have the same denominator. So what I'm going to do is I'm going to set this up, and we'll do the old 4th grade method. We can do it that way. And I'm going to set it up, and I'm going to go 8 5/6 minus 2 1/3. Okay, well, what I need to do is I need to make sure that my fraction has the same denominator, and I'm just going to use, for the lowest common denominator, I'm going to use 6. Why? Because 6 goes into 6 one time. I'm still going to keep my 5. Okay, and then my 1/3, well, I need to multiply to get to 6. You know, what do I need to multiply to get to 6? Well, I multiply by 2. 3 times 2 gives me 6, so I got to multiply up here by 2. 2 times 1 gives me 2, so I get 2/6. And then I just go ahead and replace, and I make sure I have my 8 here, and I have my 2 here, and that's my new problem. Okay, so I get this 8 5/6 plus 2 2/6. Okay, well, I am subtracting. And I got to make sure that I can subtract. Can I subtract 5 minus 2? If I can, you know, where I don't get into the negatives, because right now I have 8 5/6 minus 2 2/6. I should never get into negatives because I have plenty of, if you think of this as pizzas, I got lots of pizza here. I got 8 whole ones and 5/6 of another one, almost a full pizza. And we're only going to eat this much, 2 2/6. I'm not going to get into the negative pizzas. We're not going to eat all the pizza. So I just have to double check. And the way I double check is I'm going to use my same denominator. And I'm going to take my 5 minus 2. And I'm not going to get a negative when I go ahead and subtract that. I'm going to get 3/6. But don't forget, you got 8 minus 2 here. Don't forget that. That was your whole number. So my 8 minus 2 there is going to give me 6. And I get 6 3/6. But 3/6, well, 3 is half of 6. Or you can just divide it by 3. And when you divide it by 3, you're going to notice that you're going to get 1/2. So I'm going to get 6 1/2 as my answer. Okay, so what did I do? I go back and I look at this. What did I do? I subtracted 8 minus 2 because we're subtracting here. I subtract the fractions, okay? But I had to have the same denominator. So I had to convert the denominator. I had to find the LCD. Then I subtracted 5 minus 2. Once I was able to do that, I got 3/6. I reduced it to 1/2, and I ended up with 6 1/2 as my answer. Okay, your turn to try it. Good luck. Okay, welcome back. So we end up getting 2 1/3 minus 1 2/3. Okay, this is nice because we have the same denominator. Anytime we have the same denominator, it makes it very, very nice. But watch what happens when I go ahead and I start subtracting this. Let's just say that I go ahead and I put this into 4th grade type of work here. And we're subtracting. And I go ahead and I look at this and I say, okay, I'm going to go and I got my common denominator. And then I'm going to get 1 minus 2. And 1 minus 2, that's going to give me a negative 1/3. No. Sometimes it might come out negative, but in this case, I got this 2 1/3 minus 1 2/3. I got plenty here. Okay, I got plenty to subtract from. I should never get even to 0. Okay, because I'm only subtracting 1 2/3. If I subtracted 2 1/3 minus 2 1/3, I get to 0. But I don't have enough to subtract. So the question is, well, what are some things that I can do? Well, they call it borrowing. And what we're going to do is I'm going to show you how to borrow from, there's one way of doing it. So if I take my 2 and I have my 1/3, okay, I'm going to take the 2 and borrow a whole. I'm going to get a 1 left, and I'm going to put 3 over 3. That's 1, just in case you didn't know. And then I still have my 1/3. So if I add all this up, I'm going to get 2 1/3. But what I'm going to do is I'm going to put these two together, the two fractions together. And I'm going to get 4/3. Notice I have an improper fraction, or 1 4/3. But that's okay, because 1 4/3 equals 2 1/3. Now watch what I can do. I can take my new 1 4/3, and what I'm going to do is I'm going to get rid of all this. I could take my new 1 4/3 and subtract my 1 2/3. Now watch what happens. I have my third. I could take my 4 minus the 2. I got plenty of stuff to subtract. I end up getting 2/3. And then I get 1 minus 1, which is 0, which I end up with just 2/3. Now I probably lost you halfway in there. That's okay. I probably lost you here where I borrowed from the 2. I borrowed 1 from the 2, so it became 1 whole. And then I still have 3 over 3, and I took the 3 and added it to it, and I got 4 1 4/3. Maybe I lost you there. There's another way to do this. The other way is just to change it all into improper fractions. This is this method here. I have no problem with that. You just need to know how to do that. Well, how do I do that? Well, if I take 2 1/3, I multiply and then I add. 3 times 2 plus 1. I'll write that out. 3 times 2 plus 1. 3 times 2 is 6 plus 1 is 7. So I end up getting 7/3. And I'm going to subtract it to, I'm going to do the same thing to 1 2/3. 3 times 1 plus 2. I'm going to write that out for you. 3 times 1 plus 2. 3 times 1 is 3, plus 2 is 5. So I end up getting 5/3. Well, if I have this out, remember, we're subtracting. Put it all together. I got my 3, 7 minus 5. Voila, I end up getting 2/3. Same thing. Two different methods, two different styles. It's basically learning how to deal with the mixed number. So one way, change them all into improper fractions. That just means the number on the numerator is larger than the denominator. It doesn't mean something's wrong with it. But we could subtract as long as your denominators are the same. Sometimes you got to get those denominators the same, then you got to change them. So let's go ahead and manipulate some fractions here. Okay, so like on G, I'm going to help you out just a little bit. G here, You're probably going to want to borrow. You can easily borrow this, or you can just change 7 into an improper fraction. I'm going to give you a hint. 7 as an improper fraction is 7 over 1. These have the same denominators. These you might have to change into the same denominator. Okay? I'll give you a hint. You could use 24. That'll help you. Good luck with these. Okay, welcome back. Remember, you can pause this, you can play this, you can replay this at any given time. Just remember that. So here we go. Word problem time. An urban planner is designing a skateboard park. The length of the skateboard park is 120.5 feet. The length of the parking lot is 40 1/3 feet. What will be the length of the park and the parking lot combined? So in other words, they want the length of the skateboard park. Take out my highlighter. Right here. And we're combining with the length of the parking lot. Well, that's not too bad. It's 120 feet. Sorry. 120.5 feet. At half a foot, that's 6 inches. That's important. And then 40 1/3 feet. Okay, well, there's a couple of ways that I can do this. One is to make sure that my 1/2 and my 1/3 has the same denominator. Okay, so let's go back over here. Let's change the color. How can I get 1/2 and how can I get 1/3 to have the same denominator? 3 and 2. They don't go into 4, but they can go into, say, not 5, but 6. 3 goes into 6 2 times. So 2 times 1 is 2. 2 goes into 6 3 times. So 1 times 3 is 3. Okay, so what you're going to do is you're going to add everything up. Take your wholes out. You got 120 plus 40. Do the easy part first. You know you're going to get really close when you just add the wholes up. And this should give you 160 feet. Now you just have to add in that little extra fraction. In this case, it's going to be 3/6 plus 2/6. Or, like I showed you before, take the 6 and then take your 3 plus your 2. You add those together, you get 5/6. So now you have your 160 and your 5/6. You put it together and you get 160 feet, and 160 5/6 feet. And you want your unit of measure. Make sure you have your unit of measure on there, because that's what they were asking. And that is my answer. That would be the parking lot with the skateboard park combined. Okay, go on and do your homework. Good luck.